Alright guys, I won't be here today as you can see. I know we have a test coming up on Tuesday, and I have a rather thorough review planned here, going through that packet I gave you on Friday to help you out with that. If you didn't get it on Friday, you're welcome to flag down the sub. They will have one up front there on my table they'll be glad to give to you, so you can have that. I gave it on Friday if you were here so that you could get a jump start on studying. I'm going to go through this and going to go through a rather thorough review here so that you're prepared for your test, even though I'm not going to be here, because even though I'm not here, that shouldn't matter at all. I can't really help you on your test anyway. So whether I'm here or not, you just got to make sure you turn your brain on and you use it, and you'll be fine. If you go through the review here and you still have questions, I want to remind you of the 3 resources I gave you. One being Quizlet. You can certainly look up those topics. Another one is Khan Academy. You're welcome to go through that. Look for those videos. And Math is Power for You. Those are all some of the things I gave you. If you've watched the video and you've used those resources and you still have questions, you can email me and I'll get back to you as quick as I can on that to try to help you out for your test on Tuesday. Now, having said that, with this video, feel free to pause the video, to rewind the video, to restart, to fast forward, to jump around what you need to so that you can see, so that you can understand what's going on here. This is a study day. This is going to be an hour and a half that is for you a chance to study. It's going to be a chance for you to ask questions to your neighbors who, I guarantee there's somebody in this class that understands every piece. Maybe not one person that understands all the pieces yet, but there is somebody in your class that understands the topic you have a question about, and I want you to have the opportunity to ask them if you need to. I know some of you feel pretty confident about it, and you've had this review and you've looked through it and you said, hey, I can do that. This is your chance to kind of check your work to see if you actually know it as well as you think you do. So let's dive into this. First thing I'm going to go over here is, adding and subtracting, multiplying polynomials. First thing you always need to do is to pay attention to that sign in between them. In this case, it's adding. So we need to make sure we add when we're doing this. When you're doing polynomials that you're collecting like terms here, they have to be the same. So things like that right there, you've got to have the same base, the same exponent. So x squared, I can only go with other x squareds. So it's going to go with that negative 19x squared. When I have negative 6x, it can only go with other x's. And if you notice, I've got 2 terms there that haven't been highlighted, or underlined. It's that 7 and that 3x cubed. Now that means there's nothing that's going to change those, so I can't combine them with anything. Don't change them. So as I'm doing this, flip this around here so I can use my pointer. As I'm doing this here, that 4x squared can only go with my other x squareds. Now, you've got 2 options here. It does need to be in standard form when I'm done. It says right up there. Now, I'm not worried about the classify and number of terms and degree. That's things like telling me whether it's a monomial, a binomial, trinomial, and whether it's a cubic, quartic. I don't care about that. We're not worried about it. That's an old question we used in our old standards, so we're not worried about that anymore. But being able to put it in standard form is important. So as we go to do this, we do want the highest exponent or the biggest exponent to be first. You don't have to start with that. You could solve and collect like terms going across first and then put it in order. That's an option. If you can put it all in order at the same time, that's fine, but some people doing 2 things at once is an issue. So what we're going to do is we're going to add those going along. So I got 4x squared and negative 19x squared gives me negative 15x squared. I've got negative 6x, negative 15x gives me negative 21x. 7, there's no other numbers, so plus 7. That negative 3x squared, or excuse me, positive 3x squared, there's nowhere else to put it, so 3x cubed. I said squared. I know some of you are yelling at the computer right now. Mr. Mitchell, you said squared. It's cubed. Sorry about that. And we double check and make sure we didn't miss anything. We make sure we used all of our terms, and that's our answer. Pretty straightforward, but easy to mess up. Next one, we've got a minus. Now, if you remember, and even if you don't remember, it's still true. I said the easiest thing to do was to rewrite that and make that a plus sign and essentially distribute that negative to all of those. Think of it as like multiplying by -1. So if I'm going to do that, I'm actually going to use negative 18x squared plus 4x minus 16, but then I'm going to distribute that negative to all of those, so that becomes plus negative 15x squared minus 4x plus 13. And there I rewrote that. After distributing that, I'm going to use my colors here to mark x squared, x and x, and a constant and a constant. So, as I'm adding here, if you notice I'm adding now, negative 18x squared, negative 15x squared, that gives me negative 33 squared, x squared, excuse me. Positive 4x plus negative 4x gives me 0. I don't need to write the 0, so please don't. That's just a redundancy. That's one more thing you got to get rid of later, so don't do that. Next, I go to my negative 16 and positive 13 gives me plus 3. I double check and make sure I used everything, and I did in this instance. So that means this one's done. All right. So number 3 here, we're using the distributive property, in which we're going to multiply that first term by all of the other terms. When we're multiplying, we multiply coefficients. Those are the numbers out front. We multiply coefficients with other coefficients, and we multiply the base, in this case an x, with other x's. And what we're going to do is we're going to add the exponents when we're multiplying. So, I've used my little arches here to remind you that it has to go to every term. So I'm going to multiply this out. So that first one, 3x squared and 4x cubed. So I'm going to do 3 times 4 first, which gives me 12. X squared times x cubed, so I add the 2 and the 3, I get x to the 5th power. Go to my next term. 3 times negative 5 gives me negative 15. X squared times x, I add the exponents, and there's an invisible 1 there. So that's x squared plus x gives me x cubed. 3x squared times 10, so I got 3 times 10 gives me 30. There's nothing to change that x squared, so I just bring it down with that term, x squared. I check to see if there are any like terms I can collect, and there aren't, so that's done. Now I'm going to do the distributive property twice on this. So what will happen is the 6x gets multiplied by everything, and then the -1 gets multiplied by everything. And I should have some like terms when I'm done there to collect. So I'm going to start off. So 6 times 5 gives me 30. X times x gives me x squared. 6x times 9, so 6 times 9 gives me 54, plus the x, so plus 54x. -1 times 5x gives me -5x, because -1 times 5 is -5. Nothing to change the x, so I bring it down. Negative 1 times 9 gives me negative 9. I see here that I've got two terms with just an x, and I can combine those. So I now have 30x squared plus 49x, because 54 plus negative 5 gives me 49, minus 9. And that is going to be my final answer. Probably should have been boxing some of these as I'm going along. But if you were paying any attention to the video at all, you know what's going on. And if you're not paying attention, well, sucks to be you tomorrow when you go to do your test. Now this one, a little more complicated, or rather a little more multiplying involved, not necessarily more complicated, but you're going to have more terms. So it's more to keep up with. So I'm going to start off with that first term, 2x squared times 3x squared, so 2 times 3 gives me 6. X squared times x squared gives me x to the 4th. 2x squared times 5x, so 2 times 5 gives me 10. X squared times x gives me x cubed, because I'm adding those exponents. 2x squared times negative 5, so 2 times negative 5 gives me negative 10. There's nothing to change that x squared, so I bring it down. Then I go to my negative 1. Negative 1 times 3x squared, so negative 1 times 3 is negative 3. Negative 3x squared. I wrote it a little differently this time because what I'm doing is I'm lining up terms as I get them. I saw that was an x squared. I put it under the x squared term I already had. Negative 1 times 5x. Negative 1 times 5 gives me negative 5. Nothing to change the x, so I bring it down. Negative 1 times negative 5 gives me positive 5, because negative times a negative is a positive. And then it's just a matter of collecting my like terms. Lining it up this way has the advantage of making it easier to see where your terms belong. So if you have trouble lining those up, or you have trouble that you miss them sometimes, that's one thing you can do to help yourself. And it's going to give me 6x to the 4th plus 10x cubed minus 13x squared, because all I'm doing is changing the front numbers when I'm adding and subtracting. I'll leave that alone. And minus 5x plus 5. Double check myself real quick just to make sure there are no duplicates or no like terms I can collect. And this is a very long answer here. A lot of little terms to mess up on. Would pay to make sure that you take your time on that. All right. Let's pause there a second and let me get some more of your review going. So your next section here is talking about key features of quadratics, things like min, max, roots, solutions, vertex, line of symmetry, and y-intercept. These are all things we spent quite a bit of time on. Did our Desmos project with Google Slides, submitted those. Overall, we did pretty good. Most of what we messed up on was just things we weren't paying attention to. But overall, we're pretty good. And we're going to go through some of this. This is going to be on your test. You're going to need to answer some of these in isolation, but like this, it just flat out ask you what they are. But it's also going to give you some in word problem form, and we're going to go through some of those as well. They're a little later. They're on the end when we get to Bubba's Revenge and the rocket problem. So let's dive in what we've got here. So if you're looking for key features of a quadratic, regardless what the quadratic is, there's no reason that you can't get some of these right just by graphing your quadratic. That's what I recommend doing first. Take out your calculator, graph it, and look at it. Once you do that, you'll see that a lot of these can be answered just by looking at it, and the ones that can't, your calculator will answer for you, and I'm going to remind you how to do that when we're going through this. So if you were stuck on our last quiz, last test we took, or you've forgotten how to do that, you can always go back here and look at that, and I'll remind you how to do that. So what we're going to do is I'm going to bring up my calculator. Maybe I will. Here we go. There we go. So there is, let me clear that out of the way, what that should look like when you graph it on yours. There we go. I expanded it out a little bit so it's a little easier for you to see what's going on. So first off, if you look right here, we can see, if we're paying attention, that as that goes along, that dips below the x-axis just a little bit. So this definitely has more than one solution. The only time it ever has just one solution is when it just bounces off. It just kind of grazes that x-axis. It doesn't actually cross it, just touches it in that one point, which is the vertex. In this case, it actually drops below it just a little bit. And when we go to find our intercepts in a little bit, we'll need to pay attention to that. So that first question is, does it have a max or a min? And it definitely has a min. It's got a minimum there because it's got a low point. If I had a maximum, it would need to be facing the other way and have a high point on it. So that first question should be a minimum. How many roots does it have? Well, I just talked about that. It crosses the x-axis more than once because it drops below just a little bit there, so it has to cross twice. That means it has 2 roots. So there's 2 of them done already just by looking at it. The rest of these we're going to have to use our calculator a little bit to actually solve. So our next question is, what are the solutions? Now, we don't have to be able to tell what they are specifically just by looking at them. Your calculator will solve it for you. But it does help if you can distinguish where the solutions are. So first thing I'm going to do is I'm going to zoom, and I'm going to zoom in because I want to be able to see those a little better. Now if you notice, my vertex is over here at 0, 0, and if I zoom in right there, I'm not going to be able to see my graph. So the first thing I'm going to do is I'm going to move over. That's why it doesn't automatically zoom in, because it doesn't know where you want it to zoom in. You've got to move your cursor to where you want it to be. I'm going to move that over there. It takes me far longer than it will you. And I hit enter. And it zooms in. And now I can clearly see my 2 intercepts there. You can very clearly see that. And that's going to make it a lot easier when I go to find my solutions on my calculator. So I'm going to hit second and trace, because anytime I'm going to do math on the calculator, I've got to go to my calculate menu. In this case, trying to find a solution, another word for solutions, you've got root, you've got x-intercept, and you have a 0. So we're going to find a 0 there. Left bound, remember that means to be to the left of the point. So I've got to, if there's the point, I got to be over this direction somewhere. So I'm going to move left until I cross that x-intercept, that x-axis there. Just keep on moving left. There we go. I hit enter. Don't have to be real far past it, but I definitely need to be clearly on the other side. I need to be able to see that I've passed it. Right bound means I need to be on the right side. But one thing is important. I need to make sure I stay on the same side of the vertex. Don't move to the other side of the parabola, or that'll mess your calculator up. Hit enter. The stupid feature guess. Before I move on though, if I look at my 2 arrows here, if you have any doubt whether you got your left and right backwards on there, if those arrows are pointing at each other, you got left and right correct. If they're facing away from each other, you got them mixed up. Hit enter, and one of my zeros is -5, 0. -5, 0. And make sure you write that down if you don't have it already. I'm going to fill in some of those things on our chart in just a minute. I can go ahead and do that here. So we've got a minimum. We've got 2 roots. One of the solutions is -5, 0. And we don't know what the other solution is yet. So jumping back there, we have to find our other 0. So we hit second trace, because we need that calculate menu, because we're doing math on a graph. We're finding a 0 again. This time we need left bound, and left bound is going to be over here because there is our point and we need to be to the left of it, so over there somewhere, but still on the same side of the vertex. So there's left enough. We hit enter. We move over to the right, past that axis going to the right. I hit enter. I check my arrows, make sure they're pointing at each other, and I hit enter again. And I get -4, 0 as my other 0. I caution you on these. I mean, you can look at your table and it tends to be a little more clear, but I really caution you on these of just trying to eyeball it and say, oh, that's what it is, because sometimes it looks like it's right on a number, but it isn't. So just caution you on that. Finding the vertex. So what we're going to do, we're going to do math on a graph again. So we're hitting the calculate menu, second trace. This time we're finding a vertex. So that's either a minimum or a maximum. And we've already determined we have a minimum. So we're going to go to option 3. Left bound this time means to the left of the point we're looking for, which is the vertex. So we're going to move to the left of the vertex. Scrolling, scrolling, scrolling. There we go. To the left. Hit enter. Now we go to the right bound, so right of the vertex over here somewhere. Moving over to the left here. There we go. Hit enter. Check my arrows, make sure they're pointing at each other like they're supposed to. And my vertex is, according to my calculator, -4.499999998 and -0.25. If you remember, repeating 9s means we're actually at our next closest number right there. So in this case, it's -4.5 and -0.25. So my vertex as a point is -4.5. Let's try writing in English here. -4.5, comma, -0.25. Equation of the line of symmetry. I need the x value of my vertex, which I've already found. There's no need to try to find it again. I've already found it. It's right there. So x, y, that's my x value. The equation of the line of symmetry is x equals the x value, -4.5. Pretty simple on that, right? So finally, we're trying to find that y-intercept. I'm going to back out to my graph again. Y-intercept is where it crosses the y-axis. The easiest thing to find your y-intercept is to go to your table. The only thing I really recommend always going to your table for is your y-intercept. And the reason is because it's real easy to find where x equals 0, because that is your y-intercept, is where x equals 0. So in this case, my y-intercept is 0.20. And that's one of the few things that it's always really easy to go and find. So my x-intercept is 0.20. So I'm going to do a similar thing for number 7 here. I'll pause that while I get my calculator ready. Alright, so what I've done is I've punched this equation in. Going back to my calculator here, here's what it looks like. Also, to get back to this window, in case you have forgotten, I go to my zoom button here. I hit zoom and I go to my standard zoom, which is option 6, which gets me back to this graph here. So going through that same list, does it have a min or a max? Well, on this one, it's got a high spot, so it definitely has a max. How many roots does it have? So I'm looking at how many times it crosses the x-axis. When I look here, it doesn't cross at all. So it has 0 roots. That one's a real easy one. What are the solutions? Well, if it never crosses the x-axis, it has no solutions. Simple enough, right? Well, vertex, it always has a vertex. So let's go back to our calculator here. We're going to find our vertex. So in this one, it's important to know whether it's a minimum or a maximum. We already determined it is a maximum. So we're going to go to second, calculate. Because we're doing math on a graph, we hit that menu. We said we're finding a maximum, so we're going to option 4 this time. Left bound is to be to the left of the point we're looking for, which is the vertex. So we're already there. We're going to hit enter. I want to move over to the right of it. It'll take me about 3 days to get there. All right, I'm going to hit enter. Please don't try to stop on the point. Move where you're clearly over to the left and right of the vertex, because that's one of the more common mistakes, is they want to get like right there and say, oh, I'm to the right of it, and you may not be. Check my arrows, make sure they're pointing at each other. I hit enter again. And my maximum is 1.49999999. Y equals negative 2.75. Again, if you remember, the repeating 9 actually means that number that's right in front of it is actually the next closest number, so that's 1.5. And y equals negative 2.75. So my vertex is going to be 1.5. I'll write that a little lower. 1.5, negative 2.75. My next question is, what is the line of symmetry? For the equation of the line of symmetry. And as we've already talked about, that is x equals a number. So x equals the x value of my vertex, 1.5. Easy enough. And then if you'll remember, going back to my graph, I'm going to go to my table to find my y-intercept, because it's where x equals 0, and it's going to be 0, negative 5. So for my y-intercept, I'm going to write 0, negative 5. That's key features in a nutshell. It's pretty quick, pretty easy, pretty simple. Just a matter of remembering how to do all of that stuff on your calculator, which I did go through. So if you need to go through that more than once and punch it in a few times to remember it, that's fine. Go for it. Do it 2, 3, 4, 5 times if you need to, how many ever you need to. Let's pause that a second while I get your next section set up. Alrighty, so this next section is factoring, and you got to show all your work to get credit. That means for most of this, it's a star, setting up your star and how you set up your factors the way they're supposed to go. I'm going to go through all of that, so if you've forgotten, I'll remind you. Move into this one. So I'm going to set up my star. I'm going to check through my checklist. Step number 1, always check for a GCF. I don't care if you think there is one or not. You check for it anyway. GCF, I've told you, take the smallest number out front. In this case, it's going to be in front of that x, which is a 1. And take the biggest factor of that, which is normally itself, and see if it divides into all of them, and then work your way down. So 1, if that's the only thing that they're going to have in common, obviously we say they don't have a GCF, and we move on to our second step, which is check for a difference of squares. Difference of squares only has 2 terms. That has 3. 1, 2, 3. We don't count 0. That's like y equals. It's the same thing. So we go through here. We have 3 terms. It's not a difference of squares. So we go to our star method. Do not jump straight to the star method on all of these. Do check for those things. It's important. So we're going to set up our star. A times C goes up top. A times C. So in this case is 1 times 16. 16 goes up there. A goes on each side of it, which in this case is 1. And then B goes on the bottom, which in this case is negative 8. Just as a reminder, A, B, C is where we're getting those numbers, in case you have forgotten that. Now we're looking for two numbers that multiply to give us 16, that add to give us -8. So we're going to find our factors of 16. So 16, 1 times 16, 2 times 8, and 4 times 4. Now, just look at those pairs of numbers there. Which ones of those could possibly give us 8? And when we look, the only thing we can make out of it is 4 and 4. The problem is 8 needs to be negative. So what I need is -4 and -4. And I can do that because -4 times -4 still gives me +16. So that still works. Now I check these sideboards over here and see if they simplify. And I look, I've got a 1 on top, so they definitely don't simplify. So I'm going to write out my factors. 2 sets of parentheses. Top number is my number of x's. Bottom number is a constant that's added or subtracted. So 1x, I just write x minus 4, x minus 4, and that's it. Now, it is possible if it were multiple choice, and you have the option of writing it this way yourself if you would like, is you might see x minus 4 squared. I will accept x minus 4 times x minus 4 is not a problem. But, you've got that option there as well. So just know that you might see it that way. If you do, great. If you don't, that's okay too. Move that out of the way there. Let's see if I can move our answers here. There we go. Stem of that 4 wanted to ride along. Let's put that back. There we go. Now, number 9. I am going to solve all of these. If you don't need me to solve all of these, if you want to skip to the answer to see if you did it right, that's fine. I'm not worried about whether you have the right answer written down. I'm worried about if you know how to do it. So if you check the answers on all of these and you skip until you find one that you missed and go, oh, okay, I figure, and then watch that one, I'm fine with that. But I am going to go through all of these. So if you need to skip through these and just check the answers, do check your answers. But if you need to skip through these and check your answers, I'm fine with that. I know that you may not need all of these, but if you do, I want to give you those examples so you have them. So, first step, I check for a GCF. You always check whether you think it has one or not. This one does not, because that first term is a 1. 1's the only thing they have in common. I check for a difference of squares. It has more than 2 terms, so I'm going to move on to my star method. A times C goes in that top square, so 1 times 9 gives me 9. A goes on each side of it, which is 1, and B goes in the bottom, which is 10. I'm finding factors of 9 that add to give me 10, so I've got 1 and 9, and I've got 3 and 3. Now out of that pair, the 1 and 9 is what gives me 10, so 1 plus 9. So I'm going to put 1 on one of them and 9 in the other. It doesn't matter which one's which. I check to see if either of those sideboards simplify, and I check specifically, do they simplify helpfully? Because 1 over 1 does technically simplify to just 1, but that doesn't help us because we need 2 numbers to fill in our parentheses. So I'm going to set up my 2 sets of parentheses there. Top number is my number of x's. The bottom number is the number I add or subtract. So that's x plus 1 and x plus 9. All right, so I go to number 10, and I check for a difference of squares. I check for a GCF. Check for a GCF. The only thing they have is a 1, so that doesn't help me. So then I check for a difference of squares. My brain's ahead of me. So I check for a difference of squares. I have 2 terms. All right, so that's looking good. I checked to see if they're both perfect squares. Well, n squared is n times n, and 64 is 8 times 8. That's on that list I made. So looking good. Am I subtracting? Yes, I am. So I have a difference of squares. Can save myself a little bit of work and just set up my two sets of parentheses. So it's going to be what times itself gives me n squared. So that's going to be n. So n times n. What times itself gives me 64. That's going to be 8 times 8. One's got to be plus. One's got to be minus because I need 8 times 8 to equal negative 64. And the only way to do that is one positive, one negative. Also, I've just realized that I goofed over here and wrote x's when I should have written m's. All right. I'm sure some of you were yelling at your screen again and correcting me, and I appreciate that. I subconsciously heard you from over the distance. So, the next one, number 11, first thing I do is I check for a GCF, greatest common factor. And I look to see if there's something that will divide evenly into both terms. In this case, there is. Because remember, it's the biggest number or variable that divides evenly into all the terms. It can be both. In this case, it's not. It's just a variable. So I'm going to take the variable with the smallest exponent, which in this case is p. And I'm going to divide the terms by p. So I had p squared, which is like p times p. And I took a p away, so it's just p. Minus, if I think p divided by p, because that's really what it is. P squared divided by p is p. Negative p divided by p is negative 1. I always check to see if my squared term is gone. It is. I'm done. That one's a real easy one. Sorry about that. Circle, circle. And there's answer choices in there. Moving along to number 12. Again, reminder, if you're not needing the review on all of these, feel free to skip around and get to something you do actually need. So, number 12. First thing I always check for is a GCF. Take the smallest number out there. So this 3. Does 3 go into 8? It doesn't, so that doesn't work. My only other factor of 3 is 1. And if that's the only factor they have in common, I don't have a GCF. So I check for a difference of squares. It's got more than 2 terms. I move on. I go to my star method. So star method. A times C in that top blank. So 3 times 4 is 12. All right, A in my first blank there. B goes on the bottom, which is negative 8. So I'm looking for factors of 12 that add to give me negative 8. So that's 1 times 12, 2 times 6, 3 times 4. So I look, the only pair I can make 8 out of is going to be 2 and 6. Now the problem I have is that 2 and 6 are positive and 8 is negative. So I got to think a little bit and realize that it's not just 2 times 6 that gives me positive 12, but also negative 2 times negative 6. This number up here is positive. These down here either have to be both positive or both negative. In this case, they're going to be both negative. I've also, again, catching myself. Sorry, it's starting to all kind of run together here for me. I messed up here and did something you guys frequently do. I wrote 1 there instead of what A is. And that's a common mistake you guys made, and I just fell into it myself and don't have a real good excuse other than I just wasn't paying attention, which is normally y'all's problem as well. So I fixed that. That should be A. For those of you that were yelling at your screen going, hey, Mr. Mitchell, you did it wrong. Thank you. I, again, must have heard you subconsciously. So, now that I get to that point, and I've thoroughly confused you, hopefully I haven't too much in actuality, I got to check those sideboards, see if they simplify, and one of them does this time, and that's that 3 over negative 6. And that's actually going to simplify to be 1 over 2, or 1 over negative 2 rather. I'm going to write it in a different color here. 1 over negative 2. So now I set up my parentheses. Top number gives me number of x's. Bottom number is the constant. So I got 3x minus 2. And this one I'm going to use the simplified one. So I've got 1x, or just x minus 2. Do want to remind you, anytime you want to check yourself, you can certainly do that by multiplying that out, just like we did that first section when we were doing the distributive property. If we multiply it back out, we should get what we started with here, which is 3x squared minus 8x plus 4. 13. You've got to pay attention on 13 or you will miss it. The first thing you got to pay attention to is realize that x squared is not on the same side as all of the other stuff. If you miss that, you're going to goof up. And you'll try to use the star method as it is, and you're going to get the wrong answer. Don't do that. So the first thing you have to do is get everything on one side. Now, you can certainly move the x squared to the other side because that's the least amount of adding and subtracting work. But if you do that, you have to remember to factor out a negative, which is not necessarily a bad thing, but you do have to factor out that negative because a will be negative at that point. Or you can realize that I can move everything over to the other side and a will be positive that way and I don't have to worry about it. So that's what I'm going to do. So I'm going to do x squared, and then actually before I do that I'm going to write it like you guys should. So you're going to subtract 9x and you're going to add 20. But you're going to do that over here. So minus 9x and add 20. So you'll have x squared minus 9x plus 20 equals, since I took everything away from over here, I have 0. So that's my new equation I'm using. Now, I check for a GCF. All I've got's a 1 there, so I'm not going to have a GCF. Check for a difference of squares. I got more than 2 terms, so I go into my star method. A times C, which is 1 times 20, gives me 20. A goes on each side, which is actually 1 this time. And B, which is negative 9. Find factors of 20 that add to get me 9. So 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. And I'm looking for a pair of those that I can use to get 9. It's going to be 4 and 5 on this one. It's got to be negative 4 and negative 5. Check to see if those sideboards simplify. They do not. So I'm going to set up my parentheses. X minus 4 and x minus 5. All right. So a little extra work on that one. I have to shrink that down a hair so that I've got room for the rest of my problems I got going on here. There we go, close enough. 14, again, I've got to notice I don't have everything on the same side. So I've got to make it on the same side. So subtract 50, subtract 50. So I get x squared plus 3x minus 54 equals 0. All right, so first thing I do, check for a GCF. I've got a equals 1 up there. There's not going to be anything that goes into all of them. So I check for a difference of squares. Doesn't have any. Then I go straight into my star method. A times C goes up there, so 1 times -4 is -4. A goes on each side, which again is actually 1. And then B is 3. So I'm trying to find factors in -4 that get me 3. So I got 1 and 4. And 2 and 2. Well, 2 and 2 definitely don't work, which leaves me with 1 and 4. But I need a positive 3 when I'm done. So what I'm going to use is a -1 and a positive 4. So when I add those two, that gives me positive 3. If you're not sure, you can always check with your calculator and do -1 plus 4. And see that gives you positive 3, and do -4 plus 1 and see that it gets you -3. If you're ever unsure which way it goes, you can always test it that way. So next thing I'm going to do is check those sideboards to see if they simplify. These do not. So I'm going to use x minus 1, x plus 4. Do not forget to check those sideboards there. If you forget to check those, you will goof up on some of these. Don't goof up. All right, 15. Again, you have to pay attention and see that they're not all on the same side. So you have to move stuff. So I'm going to subtract 5 and add 5x. Subtract 5 and add 5x. So those will go away. So I got 2x squared plus 5x. And then I subtracted 5, so it's going to be plus 2. So I check for a GCF. It does not have one. Check for a difference of squares. It's more than 2 terms. So I go straight into my star method. Sorry if there's a glitch there. We had the Wi-Fi went down for a second. So, star method, A times C. So I've got 2 times 2, which is 4. Double check in here. There we go. So I do A, which is 2 this time, not 1, and B at the bottom, which is 5. So find factors of 4 that add to get me 5. So I got 1 and 4, 2 and 2. And this one I need 1 and 4. So 1, 4. I check those sideboards to see if they simplify. And that right one does. So I get 1/2 on this one. So I got to set up those parentheses. So I got 2x plus 1 and x plus 2. Alrighty. Hoping when you guys are seeing that stupid watermark's not in the way. It's not on mine, so I'm hoping it's not on yours either. We'll see. Alrighty. Let me set up our next section. Alright, for this next one, it's wanting us to graph as accurately as possible the quadratic inequality. If you notice, they just gave you 2 lines, so you're actually going to have to draw your tick marks and stuff yourself as best you can. Come that exam time, you're not going to have to graph it per se, but you're going to have to actually maybe solve some of those out on paper to be able to match it up, and you'll have graph papers, so you'll have to be able to draw it yourself. It's kind of where we go with this. Your actual test, you do have some grids on there to help you out a little bit, so I don't make you draw all of those on the test, but it won't hurt you to draw it on here. First thing I recommend doing is going to your friend the calculator. So, excuse me, let's do that. When you do that, you graph it, and it looks something like that. And what we're going to do is we're going to go to our table of values so we can get points. Now, this one was all in the positive range on our y's. And I think 12 would be all that would be reasonable to try to draw in there, maybe a little less than that. So let's see what our graph will allow us here. Zoom in a little bit on that. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is about all I can get on there. So if that's all I can get on there, then that's probably about all you can get on there without drawing super tiny. And that's about as much as this program will allow me. So I'm going to go back and get those points. So -3 was 27, -2 was 12, so -1 was 3. That's one I can use. -1, 3. -1, 3. At the point 0, 0. At the point 1, 3. And I know when I go to connect those, it's going to be pretty steep. Again, because my program requires it this way, I had to start with a dotted line, but I'd need to check and see if I need a dotted line or a solid line. In this case, I do need a solid line, so I'm going to leave it that way. Now it comes to the shading. I look on this, the big end of my inequality sign is pointing at the y, so that means y is bigger than. That's what it means. Y is greater than, y is bigger. So I'm going to look at my vertex. Bigger than means I shade bigger than that vertex, and bigger when I'm talking about y values is up and down. So bigger is up. So right above that vertex is where I'm going to shade. Shrink that down a little bit so it's not. Here we go. I'm going to shade right up there. And that's that one. And go to my other one here. So the first thing I'm going to do is I'm going to graph it, and when I do, it looks something like this right here. I'm going to be able to graph that. Also check when I've got my equation, make sure everything's on the same side, and it was on this one, so it wasn't an issue. I'm going to go to my table of values. Again, on this one, probably somewhere around -10 is going to be about the most I'm going to get on there. So I moved it a little bit so I could get my y values within -10 there. So I'm going to use that range. I'm going to go back to my graph here. I'm going to put my tick marks on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm going to clean that up just a little bit because it bugs me how much they're sticking out there. Look more like a fish skeleton than tick marks. There we go. So go back because I don't remember those points. -4, -9. So -4. 1, 2, 3, 4, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. About right there. I had -3, 3. 1, 2, 3. About right there. Then I had -2, -1. -2, -1. Is that where it turned around? Yep. And then 1, -3. -1, -3. And 0, -9. I go to connect that. I'm going to try to draw it in instead of erasing it. Because I look right here, I need a dashed line or a dotted line, depending on how you learned it, instead of a solid line because there's no line underneath there. So I'm going to draw that. Remember, it should be rounded, not pointed. We have U's, not V's. And I tried and it didn't work. There we go. Dotted line. This one says y is less than because the little side is pointing at the y. So that means y is smaller. So when I'm talking about y values, I'm talking about up and down. So bigger would be up and smaller would be down. So I'm going to go straight down on this one. So y is smaller than that line. So I color there. Okie dokie. Let me set up our next section. So this next section is super easy. There's just a concept issue. It's not whether you actually have to solve anything. It's just do you know what's going on. So no real solutions means it never touches the x-axis. So you draw me a parabola that never touches the x-axis. One like that is fine. You could also draw one like that. You don't have to have both, but you're certainly welcome to. One real solution is where it bounces off the x-axis. Again, you don't have to have both. Those are just examples of ones you might see. Both is fine, but is not necessary. Two real solutions means it clearly crosses the x-axis, just like that. So super easy on those. So this next section you really got to turn your brain on. So height of a rectangular door is 5 feet longer than its width. So let's think about that for a second. If we have width, let's call it W. That's its width, right? So the height is 5 feet longer than its width. So we're going to say the length equals W plus 5. Because it's 5 feet longer than the width. So I want to know how tall is the door if it's 3 feet wide. So it's 3 feet wide. I add 3 feet, so it's going to be 6 feet tall. Simple enough, right? What's the area of the door if it's 9 feet tall? So 9 feet tall, I subtract 3 feet. Let me back that up because I goobered that completely. Let's try that again. Hi, I'm Mr. Mitchell. No. The door 3 feet wide, that makes it 8 feet tall. Don't know where that other number came from. It was my evil twin wrote that. Just ignore him. The area of the door, if it's 9 feet tall, so 9 feet tall, I subtract 5 to get its width. So that means it's 4 feet wide. So 4 feet wide and 9 feet tall gives me 4 times 6, 9. There's my evil twin again. Gives me 36 feet squared because it's an area. Write an expression for the length of the door in terms of the width. So that's what I did up here. So length equals width plus 5. Now I want you to write the equation of the area of the door in terms of the width. So what it means, that's a way of saying multiply that out, but only using your W's. Don't include your L's. So if your width is, let's go back. It says area. Area is length times width, right? So if we do width as W times the length is W plus 5, wants me to write that equation, so multiply that out. I get W squared plus 5W. Hopefully that makes sense because I took length times width as my area. My width is W. My length is W plus 5 because it tells me it's 5 feet longer than its width. And then I just multiplied it out. I got a parabola. Using that information, complete the table and graph the area of the door versus the width. So it says graph that right there. So you're going to go to your calculator, go to y equals, type in x squared plus 5x. You're going to go to your table of values. You're going to fill in the table down here. So for 1, it's 6. For 2, it's 14. For 3, it's 24. For 4, it's 36. Now, if you notice, it skips at that point and goes to 6, which I'm going to have to get to in a minute. But you can fill those in on yours. Goes to 6, which is 66. and then it goes to 7, which is 84. So it actually skips number 5. That's just mainly to see if you're paying attention. So what we're going to do here is we're going to graph. We've got our table of values here. So if we start at 0, which is right here, it's right there. Then we go to 1, which is 1, 6. Now we have to kind of judge a little bit, because if you notice these go up by 4. So 4 would be that middle line right there. And then we go halfway up, that's going to be 6. So 1, 6. Then we go to 324. Excuse me, 224. No, I can't read. Sorry, guys. Oh, I go to 2 to 14. Part of this is getting used to this new app. I had to trade apps because the other app wanted me to pay a whole bunch of money to use it. The jerks. All right, so 324, 436, 6, 66, 'And if you really want to throw in the 550, you can. It's going to come out to be about right there. And then you connect the dots. What happens is we get half a parabola. All right, let me set up our next section. All right, so third block got a little bit of a taste of this on Friday. The rest of you are working your way up to that, but we're getting there. So we're going to start on this one here. Rocket is launched from a silo that is 300 feet underground. It accelerates at an initial velocity of 1,500 feet per second. Recall that acceleration due to gravity is negative 16 feet per second squared. It's wanting you to write an equation. Now, I'm going to give you the equation on this one, because we've not talked too much about the setup of quadratics. Your test that is on Tuesday will not require you to set up the quadratic. However, your exam, I can just about guarantee, will require you to set up at least one. But it's going to be like this, and they're just going to give you two pieces, and they'll be in the problem, and it won't be any issue. So what's going to happen, you're going to set up the function. It's going to be h of t, and that's back to function notation when you were in Math 1. That's the same thing as like y equals that we've been using. We're going to use negative 16t squared plus 1500 t minus 300. And where these numbers came from, negative 16 came from gravity, and that's always with the t squared term. The 1500 came from initial velocity, and that's always going to go with t. And the negative 300 came from 300 feet underground, so we're actually 300 feet below the ground on that one. So the first thing it wants to know is, when did the rocket come crashing to the ground? Well, the first thing we're going to need to do is graph our equation. So I'm going to go over to our calculator. And what's going to happen is, when you have that, is going to graph, and it's going to make this line look really dark, and you're going to go, it didn't graph, something's wrong. It did graph. The problem is, our numbers are so very large, we can't see what's going on. If you just use zoom out, You're going to zoom out a number of times, and you're still not exactly going to see what's going on. If you try zoom fit, it's not going to help you a lot either. What's going to happen is you're going to have to monkey with your window a little bit. So what we're going to do is we're going to go over to our window button. Now, X values, the min and max are talking about the smallest X value you're going to see and the biggest X value you're going to see. In this case, because we're talking about time, if you remember, we can't have negative time. It's not possible. So we're going to make the smallest X value we see 0 because we don't need to see any negative numbers. We don't care about them. It's not important at all. X max, since we're talking about a rocket, it might be a while before it hits the ground. We've got really big numbers there. We're going to pick a number, we're going to start at about 100. Okay? Because we're starting at 100, this X scale right here says right now we're counting by 1. We don't want to count by ones. We're going to count by something a little bigger that's easy to count by, like maybe 10. I'm going to fix that. That didn't go where it was supposed to, as you could probably tell. We're going to count by tens. Our y-min scale, so first off, we know our y-intercept, that's C on there, is negative 300. So I'm going to start at about negative 300. It'd be nice if I could see my y-intercept. My x, or my y max, that's going to be my y values. If I look in there, I've got B is 1500. Now, B stretches things. It makes them a lot taller, a lot wider, you know, that kind of thing, depending. So this one's going to be a really big parabola. I'm going to start by looking at my questions. If I look through there, question F is talking about what interval is the rocket in the stratosphere. That's above 33,000 feet. So, if it's above 33,000 feet, my Y-max needs to be well above 33,000. So let's start with like 40,000. Make sure you put enough zeros there. So I'm currently counting from negative 300 to 40,000. I definitely don't want to be counting by ones. I'm going to start by counting by thousands. And I'm going to graph it. Now, that was real easy for me to do, and I kind of talked you through it, one, because of my experience, but two, because I've already done this one on my calculator, and I knew what window I needed to use. Most of the time with your window, what happens is you just have to sit there and plug in numbers. You're going to pick a number, and it's going to be way too big, and you go, oh crap, I can't see anything, it's so squished. So you're going to pick a smaller number. Or you're going to type it in and go, well, crap, I still can't see what I need to. I picked a number that was too small, and you're going to pick a bigger number. And it's going to be picking a bunch of numbers and plugging them in and it not working, and you change it and just monkey around with it a little bit until you get used to it. And that's fine. It's better for you to just monkey around with it and get used to it than to give up on it. There's not an exact that I just hit a button and it works perfectly. It's going to be actually being able to adjust your windows a little bit. So that first question it wants is, when did the rocket come crashing to the ground? So ground, we're talking about zeros. It's a good thing we left some room down there. We can't really see it all that well, but that's okay. We don't need to be able to see it. Your calculator knows it's there. So we need to find a 0 because we're hitting the ground. Okay? Right there. So we get second trace because we need math on a graph. We're going to hit our calculate menu. We're going to go to option 2, which is a 0. Now left bound means to the left of the point I'm looking for, which is down here. So I'm going to move. I'm already to the left, but I'm going to move a little further away from the vertex just because it's a good idea. Three hours later. There we go. So left bound, I'm going to hit enter. Now for my right bound, I'm actually going to be dropping below that x-axis there. So what's going to happen to my y values is they're going to turn negative. So what I'm going to do is I'm going to move to the right until I see a negative in front of y, because I'm not going to be able to see my little spider anymore with the window I have set up. So I'm going to hit right, and it's going to drop, and it's going to drop, until I get a negative sign in front of it, and I know I've crossed over the x-axis. So I can hit enter again. I look at my arrows, they're pointing at each other like they're supposed to. I hit enter again. And it hits the ground at 93.549572 seconds. Now, generally, we're going to round to 3 digits unless it tells you otherwise. So we're going to say 93.55 seconds. Okay. So when did it come? So 93.55 seconds. Now this next question. What's an appropriate domain for this problem? Justify my answer. Well, the first thing is talking about that window I set up. I set up a window with my x values of 0 to 100. And the reason I did that is because 0 is the smallest x value I'm going to use. So it's going to be less than or equal to my x values. It's going to be the smallest one. And the biggest one is going to be this time I just found right here, 93.55. Because that's the last x value I use. After that, that rocket, according to the graph, would be underground again. And we don't want a rocket that's underground anymore. So time-wise, that's all that we need. When we're talking about domain for a word problem, it's always going to be set up that way. Actually, the only thing that's going to change out of this is going to be that second number right here, that 93.55. It's going to change to whatever that biggest x value is on there. And that's the only one that's going to change in real-world problems. You're always going to have 0 for your starting time. You have x in the middle, and you have 93.55 on there. So that's always going to be that setup. If you can remember that, you'll be golden. Next thing it wants is what time did the rocket achieve its maximum altitude? And it also wants to know what the rocket's maximum altitude was. Well, those both, talking about maximums, talk about our vertex. Time is our x values that we've been using. Time, it's our x value. So it's wanting the x value of the vertex here. Then the maximum altitude, so that's height, that's a y value, so it wants the y value of the vertex here. So if we find the vertex, we have x and y values there, and we've solved 2 questions with 1 solution there. So going back to my graph, I'm going to go to second trace, which is my calculate menu, because I'm doing math on a graph, and this time I'm doing a maximum. So I'm going to hit option 4, and I'm way down here somewhere, so I'm going to have to get moving. It's going to take me a while here. Just keep going, just keep going. It's like the little engine that could, it just keeps going. I think I can, I think I can, I think I can. Okay, almost there. And about 100 taps later, good. We finally made it over the mountain there. I hit enter. Hopefully yours went much faster than mine did. And move to the other side. I want to clearly be on the other side. Don't be lazy and skip a couple of taps of the right button that would get you clearly to the other side. I hit enter. Check my arrows, make sure they're pointing at each other. I hit enter again. Maximum is at 46.875 seconds. And the maximum height is 34,856.25 feet because that's all we've got there. Generally, we would go a little more if we could, but that's all we've got. So, 46.875 for how long it took, 46.875 seconds for how long it took. And then the maximum altitude, I have to go back and look at that because I don't remember. 34,856.25. $34,856.25 feet was the maximum altitude. And it says stratosphere begins at about 33,000 feet. On what interval of T is the rocket in the stratosphere? Now, an important part, it says it begins at about 33,000 feet. So, since it's not exactly 33,000 feet, we can use our table. If it had exactly 33,000 feet, there'd be a lot more work there. But we're going to go to our table. So we're going to go back to our graph. We're going to hit second table, second graph, and go to our table. Maybe we are. There we go. And we're looking for Y values that are bigger. They're about 33,000. So I'm going to go over to my Y values, and I'm going to scroll down. And I know from my vertex, which was about 40-some seconds there, that it's going to be a while before I get to 33,000 feet. Ah, there we are. So if I look at 36 seconds, I'm at 32,964 feet. I'm 36 feet short of 33,000. That's close enough. I can say that's about 33,000 feet. So I'm going to say about 36 seconds. But it wants to know the whole time it's above 33,000 feet. So I'm going to start at 36 seconds. And I'm going to keep going until I pass the maximum at 40 odd seconds there. And it starts its descent. So 36 to about 58. So 36 to 58 seconds would be my interval. So I could write an interval of 36 to 58 seconds. Or if it wanted T on there, if it wanted T, I could replace T up there. Generally we use X, but we could use T on there. It doesn't really matter for that one up there. I changed. So we could go up here. We're talking about our interval. We could do our lower one, which is 36 seconds. Less than or equal to T, less than or equal to 58. I would accept either of those on the test. You will have one similar to that where you have to be above a certain height. It may or may not be one that's as nice as this one. It may be nicer, it may not be, but this is definitely one like you might see on your exam at the end. Alrighty, I think our last one is Bubba's Revenge. So let's swing over and read about Bubba. Alrighty. So Bubba went to the beach with several of his buddies and got the bright idea to launch water balloons with a slingshot off their hotel balcony. I don't recommend doing that, by the way. Jethro determines that to hit the guys that beat them at beach volleyball earlier, the balloon will need to follow the model H equals negative 16t squared plus 40t plus 120, where H is the height in feet and T is the time in seconds. First off, it wants to know what's the maximum height of Bubba's water balloon and how long does it take to reach the height. So we just did one like that on the rocket problem. It wants to know height or time to get to the maximum height and the actual maximum height. So we know we're going to be dealing with vertex on this one. So the first thing we're going to do is go to our calculator. Right. Okay, so I graphed it, and I'm starting back at my standard zoom. So I was on that crazy window from my rocket problem on the last one, and I went back and hit zoom 6. That's standard zoom to get back to this screen. Mainly because it's always a good idea to start here. It's a good starting point. Sometimes you can see what you need and sometimes you don't. Now, if I look at my original equation, I'm going to bounce back to that for just a second. Maybe I will. There we go. If I bounce back to my original equation, I see that my y-intercept, which is c, that's where it crosses the y-axis, is 120. So I know that my parabola is going to go up to at least 120, most likely past it, because that's where Jethro's standing, essentially. That's where his balcony is going to be. That's our starting point. That's always going to be our starting point. Is that t equals 0 or x equals 0 there? And that's going to be your y-intercept. So that's your starting point. So if I do that, I know when I go back over here to my calculator, and I go to my window, so if I want to set x min to 0, I can. I can see my maximum x value, so I don't need to mess with that anymore. Don't even have to mess with the minimum if I don't want to, but I'm certainly welcome to. Y minimum, I can go to 0 on that as well if I want, because I don't need any negative values on this one, as Bubba's Hotel is not underground like the rocket was. My Y max, I'm going to go over 120 feet. So I'm going to start with, I don't know, I'm going to go 130 and see if that's big enough. I know whether or not it's big enough, but I'm going to do this for you because I didn't do it on the last one. Y scale, so I'm going to count by 10s, should be enough there. Could count by 20s if I wanted to. I'll see how it looks on there, and I'm going to graph that. And we notice we're just a little shy of being able to see what we need up there. So what we're going to do is we're going to go back to our window. We're going to change our Y max values. So let's say 160, because I'm going to be on the other side a little bit. And let's go ahead and change that to 20 instead of 10. And I graph that. And I can pretty clearly see where it crosses and our maximum there. So what we're going to do is we're going to hit second trace because we're trying to find a maximum, which is option 4. Left bound. Now on this one, my equation tends to get in my way a little bit, so I got to pay attention where my spider is here. But x equals 5, y equals negative 80. So right now I'm like down here somewhere. So I'm going to hit the left button until I can see my spider again. Sorry, the app was acting up for a second. I had to pause, keep going. Almost there. Three hours later. There we go. I'm on the left side of it. I can hit enter. I'm on the right side of it. I'm going to keep on moving. Just keep moving. Just keep moving. There we go. Hit enter. I see my arrows are pointing at each other. I hit enter again. And I get my maximum height is 145 feet, and my time to get there is 1.25000023. And if you remember, I said repeating zeros means normally just keep that value right there. So we got 1.25 seconds and 145 feet. So we have 1.25 seconds. And we've got, I've already forgotten, 145 feet. So 145 feet. If you'll notice, I wrote them in the order that it asked them. That way it's clear. But even if I didn't do that, I definitely need to make sure I include my labels so that I tell which one is which. That is extremely important when I have two questions. So if you see that on your test, make sure you put your labels, hint, hint, hint. Make sure you put your labels so that I tell which question is being answered on which one of those. So, that way I don't think you're trying to tell me 145 seconds and 1.25 feet. All right? Appropriate domain for this function. So, we already know, I told you from the appropriate domain on the other one, it's going to look something along the lines of this. I'm going to use t this time. I used x last time. I'm going to use t. It's the same thing. It's going to look like that. And the only thing that's going to change is that maximum x value, where in this case the water balloon hits the ground, right? Or if Jethro did his math right, hits those guys that played beach volleyball. So we're going to go back here and we're going to need to calculate a 0 over here to determine our domain. So we're going to hit second trace because we're doing math on a graph and we're trying to find a 0 this time. So 2, I'm going to go make sure I'm left bound. Going along here. Take me about 3 days. Whoop. All of a sudden it decides to do what it's supposed to. There we go. Hit enter, right bound, and again, because I can't see it, I'm going to need to watch for where y goes negative. So I'm going to hit right until I see, there we go, we got a negative number. So I hit enter. Check my arrows, they're facing each other. I hit enter again. So my 0 is at 4.26 seconds. Approximately. So I'm going to go back. I got 4.26 approximately. Right? Good. So the water balloon's height after 3 seconds. You've got 2 options for this. One is to plug it into that equation. So t equals 3, so I plug in negative 16 times 3 squared minus 4. You can do all of that. But what's much easier, and I recommend, is go to your calculator in your table of values. So second graph, go to your table of values. And go to where x equals 3. Now on yours, it's probably easier to just graph, but I went to the table setup there so that I could jump there and not have to take 30 minutes for you to watch me scroll through that. In this case, 3 seconds, it's at 96 feet. So x equals 3 is 96. It'll do the calculations for you. It's very nice that way. So I'm going to hit resume. So after 3 seconds, it's 96 feet in the air. Next one, how long does it take for the balloon to hit those jerks from yesterday, assuming that they're laying on the beach? The reason it says they're assuming they're laying on the beach is so you don't have to try to figure out how tall they are. Okay, so we're assuming it's flat. So we're trying to figure out that 0, which we did earlier. How long does it take to hit the beach there? 4.26 seconds. That was the bigger number, the upper bound of our domain. All right? So I've got to readjust here so that we get those last couple questions in about Bubba's Revenge. So, height of Bubba's balcony. That is C. That's your y-intercept. You can also go on your calculator and see where x equals 0, like we found our y-intercept before, or you can just look at C. And C on ours, if you remember that equation, I'm just rewriting it from up top. Negative 16t squared plus 40t plus 120. What's the height of the balcony is going to be C there. So 120 feet. That's the starting point. Right? So, Jim Bob bet Jethro that the balloon was above 88 feet for more than 5 seconds. It wants to know who won the bet and what interval was the balloon above 88 feet. That's really kind of the same question, but going along there. So we have to figure out when it was above 88 feet. Now the challenge with this one is you have to remember you can't have negative time. So when you go to do this, if you can't count any time less than 0. So I'm going to go back to my table of values. And I'm looking for where it was less than 88 feet. All right. Now the temptation is to go on back here to these negative numbers, because if you look there, I've got some numbers that are less than 88 feet there, but you can't do that. I've got to use these values in the positive region. because you remember you can't have negative time. There we go. So I started at 120 feet. I launched it, went up to around 144 plus 136. I'm down 96, so somewhere between 3 and 4 seconds, right? It drops below 88 feet. All right? And I think I've said that wrong a couple of times here. I hope I didn't confuse anybody. I can't go back and fix that. I need above 88 feet. So my starting value is above 88 feet, right? My starting value is above 88 feet. So I'm going to scroll down. 120 feet is above it. So 0 seconds is above 88 feet. At 1 second, it's still above. At 2 seconds, it's still above. At 3 seconds, it's still above. But between 3 and 4 seconds, it drops below 88 feet, right? Yes, I hope everybody sees that, between 3 and 4 seconds. So, on this one, Jim Bob was wrong. So, Jethro won the bet. Jethro won. Because it was, the interval was 0 to, let's say, 3 seconds. Oh, maybe I will. Zero to 3 seconds. So, is what we're going to say there, roughly 3 seconds there. It may have been a little more or less. Well, definitely a little more there according to our graph, but that's close enough for what we've got here. On that, it's also wanting you to graph. It gave you a graph there to help you out, and that's just going to use your table of values to graph it. Something you could do is use your table there to help you solve, and I'm going to go through that real quick. Be the last thing I do on here. So let me pause that a second to get that ready. So if you go to graph this, I gave you plenty of room. Easiest thing to do would be go to your table of values, and that way you can, it does all the math for you. So you go 0, 120, go 1, 144, and you're going to have to estimate here because it's not perfect. 1, 144. I'm going to go 2, 136. 2, 136, so again, an estimation. 396. We go 424. And we found out just over 4 was our 0, like 4 1/4 or something like that. You can estimate that if you want to, but it's not strictly necessary. And we're going to draw our parabolic curve there. Something that would help us out there. We don't have to go into the negatives because we don't need the negatives. Now, if we were actually going to look at when it was above 88 feet, something we could do to help ourselves a little bit would be to go to about 88 feet, approximately. It's going to be right below the 90 line there. Draw ourselves a line. And we know that everything above that, that's within that zone of the inequality, that whole region right there is the one that's above 88 feet. And if we were asked to graph that, or if we were to ask to match a graph, hint, hint, if we were to ask to do one of those on a test or an exam or something along those lines, hint, hint, that's how you would do that. Is you would draw that line to cut it off and shade right in there where that line goes. All right? So, overall, most of what we've done already in class, maybe a twist here or there, little stuff, but nothing big. I hope you found this informative and useful, and you can use this here and at home to study so that you are prepared for your test. And I will see you guys, I don't know, it's probably going to be Thursday before I get to see you guys again, unfortunately. So remember to bring your headphones. When you're done with your test on Tuesday, you are more than welcome to occupy yourself quietly. And do make sure you do your best on that, because there are retakes available, but it's always best to do your best the first time so you don't have to worry about scheduling a retake. Okie doke. Y'all have a good one.